Hi, this is Mrs. Slater, and in Chapter 3, we're going to hit the first 3 sections pretty fast, and because it's a lot of review, and we'll start with Section 3.1, Relations and Ordered Pairs. So the main things I want you to know from 3.1 is the fact that we've got domain and range. Domain and range, domain are the x values, and the range are the y values. So keep that in mind when we are trying to find the domain of this relation. A relation is a relationship between numbers, which is what ordered pairs are. So if you look at the x values, which are 2, 1, 1, and 1, with all those repeats, you do not need to write them over and over again. And a good way to write it is domain just with a D, and then we can just list them in set notation, 2 and 1, and not in any particular order. The range, on the other hand, are the y values, and in set notation you can see we have a 2, a 1, a 2, and a 3, and again we don't have to write the repeats, so our range would be a collection of these numbers, 1, 2, and 3. And that's the main thing from the first section. Now in the next section it talks a little bit more about the graphs. For example, how do you plot points? Well, for 3, 5, we're going to go over 3 to the right and down 5. And then label that, I'll just go ahead and label that point A. Label that point A. And then also, -2, -1, you would go to the left -2 and then down 1, and we'll call that point B. Okay, so again, you're just remembering things that you've done before. Plotting points is one of them. Determining whether given ordered pairs or solutions of the indicated equation is another. So keep in mind when you do these type of problems that this is your x value and this is your y value. So it's just going to be like a substitution problem. So 4 is going to go underneath the y, and x is going to go underneath, or -1 is going to go underneath the x. Please be pushing pause along the whole entire video just to make sure you're writing everything down. Okay, so let's go ahead and solve. The goal here is to get both sides to equal each other. And as you can see, 4 does not equal 7, so therefore we would say that -1, 4 is not a solution. Nope, not. Okay, so then go ahead and push pause and see if the next one is a solution. So hopefully you found that this was also not a solution. This is x, this is y, and if we replace, we have 5 equals -2 squared. Notice I use parentheses. Please do that as well. So you remember to take -2 times -2, because there are 2 of them, and that equals 4, but 5 does not equal 4. So therefore, -2, 5 is not a solution to the equation. So what does the solution actually mean? Well, if you have a graph like this one right here, -2x plus 5, you'd go up 5 and down 2 and over 1, and so on. So I make a line, and -1, 4 is over here, and it lands right here. So it's not a solution because it doesn't land anywhere on the red graph. Now blue graph. Since it doesn't belong there, so we can show it through algebra or we can show it by graphing. Okay, so let's go on. Also in this section you would need to know how to graph. We already started with 1, but just as a reminder, the 1 at the end is going to be the y-intercept. And the y-intercept is the 1, which is where the graph crosses the y-axis. So that's a very important part of a graph. So go ahead and look at the next number, which is the -3. That is considered the slope. That's going to give you the direction of how far to go to the left or to the right. So let's try this. Push pause, try it, and then check your answer. Okay, so we start at 1, and then the slope is -3 and then there's an invisible 1 underneath there. So we go down 3 and over 1, and then we continue this pattern. And you can go in the other direction as well. A positive 3, negative 1 is still a negative 3. And then we have a lot of points, so we can connect all those points together. And it looks something like that. Arrows on the end, because it does go on forever. And voila, you got yourself a graph. Go ahead and push pause and do the next one. And before you start, this is 1/2 x minus 2. It just doesn't look very good. Okay, so hopefully you started at negative 2 and then went up 1 over 2 and continued that way for a long time. And then again, if you want more points, you can always go in the opposite direction and get many points. Connect them with the straight edge, and there is your line. Looks something like that. A line's going to have the arrows on the end, and that's how you graph. Okay, so next we're going to talk about functions and what is a function. First of all, the notation is f of x, and if you're determining if a function is indeed a function, you're going to look at the x values. The x values, if there are no repeats, then you have a function. And then if you have repeats, then it will not be a function. So let's look at the following. I've asked to click and drag. So on your examples, just go ahead and circle the x values and decide, do we have repeats or not? Okay, so since there are repeats, then we're going to click and drag it to the not function side. Okay, the next one you'll notice, it has a 9, a negative 5, and 3 as its x values, so that means it's going to be a function because all 3 of the x values are different. So let's go ahead and move that to the function side. So next part, go ahead and click and just write down which ones are functions of the last 2, and if they are a function or not. So if you put them both under function, you are correct. More about functions is how to find function values. And basically it's whatever x is, a function value is the y value. Where does the graph go through the y? Or what is the y of the ordered pair? Okay, so when you look at a function that's given, what you're going to do is find f of negative 1. So this negative 1 is going to be replaced here and here. So let me show you. So the x is gone, negative 1. So everywhere I see an x, I'm going to put a negative 1. And this one, I'm going to go ahead and put a parentheses in there just to make sure I don't forget. And then I solve. I don't do anything to the left side. And then 3 times 1 is 3, plus 1 is 4. And the function value then is 4. And that would be the final answer. So let's try another one. Go ahead and push pause and do f of 0 and f of 1. So let's compare answers. If you take 0 and plug it in both spots, so this would also be a 0. F of 0 equals 0 times 3, which is 0, plus 1. So f of 0 is 1. F of 0 equals 1. So that is called the function value. The next one, your answer should be equal to 4. Okay? And the best for last. These are a little tricky, but again, if you can just remember that everywhere you see an x, we're going to replace that value with whatever is inside of there. So 2x is going to go here. Let me erase some things. Okay, so now focusing on the right side. 3 times, this is 2 of them, so there is 2x and 2x plus 1. 3 times 4x squared plus 1. for a final function value of 12x squared plus 1. So f of 2x, if you start with a variable, you're going to end with a variable on both of these, and that would be your function value. Okay, go ahead and push pause and try x plus 2. When you do the more challenging problems, it's easy to set it up this way, and you can tell exactly where you need to replace x with its new value. And in this case, it was find f of x plus 2, so we're replacing the x there, and then also on the right side. Okay, don't do anything to the left side, it's just format. But the right side, we have a little foiling to do. And we know that that is x plus 2 and x plus 2. And if I multiply that together, it'd be x squared plus 4x plus 4. Don't forget the outside and inside terms. In order of operations, distributive property is next, so I'm going to distribute that 3 throughout the whole thing. And for the last step, I'm just going to combine like terms, which will leave me with 3x squared plus 12x plus 13. So that is the function value when it's f of x plus 2. Starts with an x in the original, so you're going to have x in the answer as well. The last topic is finding the domain of functions. Unfortunately, I'm not going to have enough time to talk about it in this video, but that's where we're going to start up the first thing in class tomorrow. See you then.